Good morning, everybody. Today we've gathered here to have a webinar on stimulating oceanic process using telematic software. And I'd like to invite Vandana ma'am to address the gathering and also take us around the topic.
Very good morning to one and all gathered here. It's my pleasure to welcome the resource person of today's webinar and my dear student, Mr. Raam Balaji, who is working as project scientist at INCOIS. Welcome, Ram. It's my privilege to welcome my dear students and faculty members for this webinar on simulating oceanic processes using Telemac 2D software. Firstly, I would like to say a few important points about the organization where our speaker is working with for our students. And then we'll be introducing the speaker and then we'll be having the session. INCOIS, Indian National Center for Ocean Information Services. It is an autonomous organization of Government of India under the Ministry of Earth Sciences located in Hyderabad. INCOIS provides the best possible ocean information and advisory services to society, industry, government agencies, and the scientific community through sustained ocean observations and constant improvements through systematic and focused research. Today, I'm proud to say that my student, Mr. Raam Balaji, who did his project under my supervision and obtained his graduation in 2018, is going to explain you all about the Telemac 2D software, which is used for numerical simulation of tidal circulation and advection dispersion study using Telemac 2D software. I'm pretty sure most of you are hearing this term Telemac 2D software for the first time. So let me say a few important applications of the software. It is being used in the maritime field, particularly for harbor structure design, studies of the effects of building submersible breakwaters or dredging works, the impact of discharges from a sea outfall, study of thermal plumes, and with regard to the rivers, the impact of various types of construction like bridges, sills, groins, and for dam breaks, flood studies, transport of dissipating or not dissipating traces. Don't worry, children, you will be given good knowledge about each and every aspect of this software. So this Telemac 2D software can also be used for a number of special applications like industrial reservoir failures, avalanches, falling into reservoirs, and so on. So with this short note, I once again welcome the speaker of today's session, Mr. Raam Balaji. Over to Bathymetry. Thank you.
Thank you, ma'am. First of all, I'd like to say a few words about Raam Balaji myself. Hello, sir. It's a really impressive resume and work you've done here. I myself went through all your work to just give a note about you today. And about Ram, sir, he has done his civil engineering, as ma'am said, in college. He's done his UG in our college, and he went on to pursue his MS in IIT Technology in in ocean engineering. And about his coursework, it's usually about oceanography, coastal engineering, river technology, river engineering, wave hydraulics, and so on. His skills are planning and modeling, AutoCAD, Revit, and also when we speak about his research work, it's not just one or two. He has done so many projects that make us all in awe. So his project, his MS project, is about method to control sedimentation at river confluence using spur dike. And his BE project, which was led by our dear Vandana ma'am, is about strength evaluation of geopolymer concrete using base materials. There are other projects which he has taken over, as in the ocean wave prediction using machine learning, and marine plastic visualization using NOAA data set. There are also his publications which involve, excuse me, yeah. There are also his publications which involve other researches, and he's currently working in, as ma'am said, he's working in INCOIS Hyderabad. Also, he has experience as project associate in NTC PWC IIT Madras. Also, he is an implant trainee. There are certain achievements and awards which he has actually qualified GATE, which is like my dream. So I just have a personal question for you. How does it feel to be a chief guest at a college which you have studied in at a very young age?
This opportunity, first of all, thanks for Dr. Vandana ma'am. Recently, I met for getting some signature from college HOD for joining as a project scientist in INCOIS as a verification point of view. At the time, we discussed about this Telemac software, and as a civil engineer, we never thought about coastal engineering is a part of civil engineering. So I want to deliver this speech. First of all, to change the topic which we usually take in a final year project, and as well as the GATE, I cleared GATE after joining IIT. I got training from IIT professors because I joined as a project, but they encouraged me to study for your GATE project and all. We'll start later. Like that, some cooperation I got from professors from IIT also. And with our guidance with our Dr. Vandana ma'am also guided me in this field, ocean.
It is a really impressive resume you have, sir. Maybe you would be my new role model, I guess. So I'd hand it over to you. Please, can you please go ahead, sir?
First of all, I will share the screen. Is it visible?
Not yet, sir. Yes, it's visible now.
Yes, it's visible. Yeah.
Thank you for this opportunity. Today, I am going to talk about the modeling of coastal hydrodynamics. First, in this topic, majorly I am going to cover the east coast of India, Bay of Bengal, their tidal circulation and advection dispersion study. Usually, the advection dispersion study is nothing but if we pour any base material into the ocean, how it is dispersed and where it is affecting. That is the main concept of advection dispersion study. I will carry on with them. First of all, we have to check what is the role of the civil engineer in coastal engineering. There are so many structures. We are usually in the land-based structures, which we will study in our BTech curriculum. In this, the major loads we will calculate are live load, dead load, and wind load, earthquake load also will include. But we don't care about the coastal structures, port and harbor structures, and offshore structures, which are not a part of our curriculum. In that type of structures, the additional loads which are calculated are hydrostatic load due to the standing column of water, and wave, tide, and currents. These are the various components which are also have to be included. For that, we need to model the various component forces which is acting on the structures. Majorly, this coastal regulation zone, which has been a part of the like we will index the coastal regulation zone based on the tide level. Our tide levels also changing. You can see this. This is the low tide line, and this is the high tide line. Based upon this coastal regulation zone has been formulated, which is taken care by the National Forestry and Environmental Protection persons. And for maintaining the coastal structures and port and harbor structures are a part of the coastal regulation zone. First of all, we will see the foreshore structures. This is the groins. These are the groins. Groins are nothing but the structure which are built using rocks or timber or wooden poles. For this structure, we need to know the tide level, because the top level of the structure should be above the water level. So that the protection will be better enough to protect the coastal line. And jetties are similar structures, but it will be in the estuary zone. estuary zone is nothing but the connection between the ocean and the river. And breakwaters are also a similar type of structure, but it will be placed perpendicular, parallel to the coastline. These are the various structures which are used in the coastal zones. In this picture, we can see that barges or boats which are grounded on the surface. Usually, we think it is a shoreline. They kept the structures, they kept the barges there, but it is not like that. It is due to the tidal variation. This is the level of the water which was previously existed in the spring tide. There are two types of tides are there: spring tide and neap tide. I will explain in the later on. Can use in this video you can see the water level is going. This is a navigation channel which is attached to the ocean, and again the water is coming back. This process is known as ebbing and flooding. It is a part of tidal circulations. This first of all, what are the causes of tides? These tides are caused due to the gravitational force between the moon and the sun over the earth. Usually there are two types of tides, that is spring tide and neap tide. Spring tide is actually occurs during the new moon and full moon time, where that earth and sun and moon all in the straight horizontal plane. The water will be bulging, so that this is the zone where the high tide is actually present, and this is a zone where this low tide is present. And the neap tide is nothing but in spring tide we can see that high tide and low tide, and in neap tide we can see the high tide and high low tide. That is due to the lunar day and everything. This tidal current, the tidal range will be differing. And there are various type of tidal tides. We are in the coastal zone. We are expecting. One is diurnal, semi-diurnal, and mixed diurnal. Diurnal is nothing but in a day we will expect one high tide and one low tide. In a semi-diurnal, we will expect two high tide and two low tide. In with the equal height, we will expect. But in a mixed diurnal, we will have similar like semi-diurnal, two high tide and two low tide. But the range of high tide will be varying, which will be further clarified after seeing the simulation results. First of all, I will explain what are the data sets required and what are the softwares required to simulate the tidal circulation. First of all, bathymetry. Bathymetry is taken from the JEPCO. JEPCO is a gridded bathymetry data which is given by the national organization, which is an open data source. We can download the bathymetry based upon the lat long our specification, and tidal input is given by the TPXO data, which is nothing but tide model driver and projection system, which is also an open source. This is the global mapper, image of a global mapper. In this, after getting the bathymetry from the JEPCO, we have to convert the geographical system, projection system. Usually in Telemac 2D, it will accept the projection system of WGS84, which is nothing but there are various type of projection system, which is more related to the GIS and remote sensing people. For us, just we have to convert the system from UTM to WGS84 projection system. Then what are various softwares which we'll use is global mapper for converting this projection system, and the ArcGIS is to create the domain boundary. This is the domain boundary which we have to create, because we are going to simulate the process which is actually happening in this domain. We have to sketch that outer boundary line, this and the coastal line, using the ArcGIS software. Then Blue Canoe is a software. Blue Canoe is a software where we will create the mesh and we'll import the bathymetry over the mesh. These are the meshes. because from this outer boundary we will give the input as a tidal input, and it have to be simulated over the region. But usually we will make the meshing. Two type of meshings are available. One is regular gridded base, and another is unregular gridded. This is unregular gridded because there is a depends upon the bathymetry. This the process which is simulating in this zone will be taken care best by the unregular gridded mesh. And these are the various points we are going to see the results from this simulation: Nellore, Chennai, Kudalur, Nagapattinam, Tuticorin, and Kanyakumari. Whatever the process we have done, we have to give it as an input file to the Telemac 2D. Telemac 2D is a Python program. We don't need to, there won't be any GUI to operate with it. Only we have to give the input files as a steering file. Steering file is given as a .cas file. In this file, we will mention what are the boundary files and various inputs that we are giving. And this is the boundary file. Boundary file means what are the boundary conditions which is given in the ocean and as well as in the coastal zone. Bathymetry file is like topography bathymetry that we are getting from the JEPCO, and tidal input is given as a data set from the TPXO. This is the steering file, that is the .cas file. In this, these are the various components that we are giving it as an input. There will be a series of input variations will be there. We have to select whatever we required based upon the manual supplied by the Telemac. Initial condition is the constant elevation. Our water surface is constant. That is the basic idea between, and the law of bottom friction, because usually our bathymetry or any surface will have a friction that is given taken care by the Chassis law. Chassis law, it's nothing but the Chassis law is nothing but the based on the topography. There is an equation that will calculate the bottom friction, and turbulence model, K epsilon model. You might have come across the turbulence things in fluid mechanics. That for modeling the turbulence in the oceanic process, we usually use the two equation model. There is a K sigma. K is nothing but the turbulent kinetic energy, and the sigma is nothing but the dissipation. The two equation will be there that will be solved during this process to simulate the turbulence in the oceanic process. And the solver, because we are going with the hydrodynamic problem, that tide is comes under hydrodynamic problem, and the solver option is this conjugate gradient on normal equation. This is a type of method they are following to solve the basic continuity and Navier-Stokes equation to simulate this process. And liquid boundary condition is Thomson method. There are various methods are there. We usually will prefer this Thomson method. This is nothing but how the water is entering from the outer domain to the inside our domain. This is a geographic system, and these are the various basic inputs which are given into the system. First of all, we'll go on with each and every process. These are the mesh details. This is the boundary line we got from ArcGIS, and these are the mesh which that system created by the Blue Canoe. The main concern is wherever we are getting the input or we are interested, there should be like fine mesh should be there. For that, we are using from Kanyakumari to Visakhapatnam 100 meter, 1000 meter mesh size. 1000 meter is we will see that 1000 meter is related to 1 kilometer, but in ocean that 1 kilometer is a fine resolution. That is a maximum resolution that we can get in the ocean, and gradually increased beyond the study area. This is the study area, and it should be gradually increasing. Otherwise, the system will stop the simulation and it will show the error. And boundary details. There are two boundary conditions which we have given. Like this is the Bay of Bengal boundary. That for that we have given the Thomson method. The tidal elevation from the Bay of Bengal is given as a boundary condition to this domain. And what are the errors which will face while if we give the boundary details wrong? First of all, in this process, the tidal station from Gully and Galatia Bay, these two tidal data is given by interpolating manually to the domain. We can see the that simulation is not like a actual tidal simulation, because there is no tidal variation which is given as an time series. Just we have given the two tidal data from these stations, but actually this is the actual TPXO data that we have given. You can see that this tidal circulation in this zone. This is an actual tide. If you observe a data from this single point, we can observe that high tide and low tide are changing based on the topography. This is the bathymetry error that will face because JEPCO is a data which is giving a 30-meter arc resolution data. There will be an error because of interpolation. And these are the error point which we in this zone I have observed, that we can manually correct by, because it is a gridded data which will be in the NC format. NC format is nothing but net CDF format, which is a gridded format. Actually, we will have the Excel data if we present in Excel. That NC format is nothing but a stacking of different Excel files that we can view, and we can edit the error points. And this is the post-processed bathymetry data. And this is the simulation of a tidal circulation. This one relates to the free surface elevation. Means actually from the surface, whatever the elevation changes, it's the tide that we will observe. And this is the tidal velocity. We can observe that near the shoreline, that velocity is more because of the obstruction which is given by the boundaries of our countries. And in this zone, we can observe more velocity. That is due to the contraction of the contraction made by the Sri Lanka and Indian boundary, so that whatever the volume of water which is coming, it is contracted, so the velocity of the zone is increased. If we see in this zone, we will observe more tidal range. These are the tidal variation at different zone, which already I have told. These are the points we are going to collect the data. In Kanyakumari, we will observe more tidal range. First of all, I will explain what is tidal range. This is see this point, the 21/11/2022, and this is 25/11. There is a four days data. We can observe that 1, 2, 3, 4, 5, 6, 7, 8. 8 high tide. Whatever the level above the zero reference line is the high tide. Below the zero reference line is the low tide. There are 8 high tide, means 2 high tide per day and 2 low tide per day. And we can observe it is increasing, and again in this time series it is increasing, and again it is reduced, and again it's some we can observe the data is some correlation between the data. This is due to whenever the moon is coming and moon and sun are in the same line to the earth, we will observe this type of tide for 15 days. This is spring tide, and whenever the moon is crossing from the straight line to the 90° to the sun, there we will observe the neap tide. Like usually in ocean environmental observation, they will collect the data for 15 days because to capture both the high tide and neap tide. And this is the validation This WX tide is it's an observation we got from the tidal station, and this is the zone where because we can't able to get the tidal variation near to this zone because the mesh size is like that, and we just correlated the observation, and that blue color line indicates the Telemac, and the red color WX tide. We can observe a great correlation, and there the peak difference is there. That is due to different zone we have observed. This is around some kilometer variation is there, because we didn't get any tidal station near our Telemac simulation zone. And this is the tidal constituents. Tidal constituents is nothing but that lunar day, the moon is revolving around the sun, revolving around the earth. Based on this gravitational difference between the sun and the earth, and moon and the earth, this will create a various tidal constituents. This M2, S2, these are the various tidal constituents, and in a single zone, I have like for east coast of India, we have collected the data and we did this time series analysis. We observe that M2, S2, K1, and K2, these are the major constituents, and the period is nothing but for each principal lunar to evolve in this zone is 12.42 hours time gap will be there. Again, this M2 tide constituents will happen, and these are the frequency from the period. We will calculate the frequency, and this is the frequency from the simulation case. It is quite well matching. And this is the another study. This is an advection dispersion study. Now we previously we discussed about the whole coast of east coast of India. Now we have downscaled our model to simulate only a particular region, that is near the Ennur. This is the our domain. In this domain, we have included the Pulicat Lake and Kosathalia discharge, and there is an power plant which is located near the Ennur. This is the outfall and intake. Intake is nothing but we will consume the water from the ocean for the power plant purpose, and again they will outfall the wastewater into the ocean. This is the process usually in power plants they will be following. In this, our study is to, if from the outfall there will be a high temperature water will be discharged, how that discharge is circulating and how it affects the zone. Based upon that, we will decide the intake, because in the intake that high temperature outfall water should not be included, should not be sucked into the system. So that we have to decide the intake and outfall position. So this study has been conducted. The ambient temperature which is prevailing in the ocean is around 30 degrees Celsius. The source temperature from the outfall 33 degrees Celsius. Even 3 degrees Celsius difference also will make a greater difference. And outfall discharge is 2.2 meter cube per second. This is like same process which we have done for the overall domain of east coast of India. This is the computational mesh, and this is the bathymetry data we collected from the JETCO. And input condition, that boundary conditions are, there is a 3 boundaries. One is 3 boundaries are in the ocean side and one in the land side. In ocean side, we have to give this TPX or tide data. Here also we can observe that this is a 15 days tidal variation. This is a spring tide and this is a neap tide. That is given as an input for all the 3 boundaries. And wind also is one of the input which we are giving into the domain. That is taken from the ECMWF. This is the organization controlled by the international association, which will give the wind input. At each domain. This is a windrows diagram. You might have known about the windrows diagram in we might have come across in our curriculum. this circular diagram with a different direction, northeast and northeast. This is like a 360 degrees divided into different direction, and this different color variation shows the velocity of the wind, which is given, which is prevailing in that zone. This data is given into this domain. And tidal circulation. This is the result of initial study. Tidal circulation is nothing but we can. This is the river and this is the ocean domain. This is the initial step, and we can observe a ebbing process. Ebbing is the water is coming out of the river towards the ocean, and the flooding process is it's a reverse. From the ocean, the water will be given as an input to the river. Initially, I have shown a video that the water in the navigation channel is drained. That is due to this process. And again, ebbing. It is a continuous process. It's a cyclic process. So we are calling it as a tidal circulation. And we have validated for our study with Kankara et al. 2013. This tidal range is validated, and tidal regime is a semi-diurnal tide because too high and too low tide is happening, and the current speed. This is maximum current speed is observed at North Chennai region is around 0.08, but in our present study it's around 0.06 to 0. There is a variation, but it is an acceptable range, and various cases have been carried out. I will show the results of these cases. Like if we include only tide, how the advection is happening. If we include a tide and wind, and we include a tide, wind, and discharge from the river channel, that Kosatalia river channel, how that will behave. This is the simulation case for tide, wind, and discharge. Three things are included. That is, tide is from the ocean, and the wind is also given in the ocean domain, and discharge from this Kosatalia river. You can see the animated video. We can observe the high velocity in this zone. That is due to the contraction of the river channel. That is, the space is very less. As the area is reduced, the velocity will be increased. This is a Bernoulli's theorem, and these are the intake and outfall location. Here only the temperature plume will be given as an input. You can see in this video or animation. From outfall location, the high thermal effluent is given into the ocean. You can see how that is affecting the whole domain. Because we can see that the high temperature water is also entering into the river zone also. This is the one case. This is the actual case which is happening in the domain. And this is the another case where wind and discharge is switched off. This is only the tide. You can see that in the surface that arrow mark is going front and back. There is no influence of wind is there. Because of this case, how the temperature plume is dispersing. Because if we consider only the tide, this outfall location is this distance between the intake and outfall location is under predicted, because it is actually it's going into the intake location, but which is not an actual case. And this is like various simulations. I will show the final results. This is the case 1, case 2, case 3, and case 4. We can see a lot of variation in this thermal dispersion in between the outfall and intake location. But this is the actual inclusion of all the parameters which are prevailing. If we see in this point of view, there is no impact of this outfall location on the intake location, so that the prediction of the distance between these two locations is correct. But this main motive of this case study is to understand how the wind and discharge plays an important role in tidal circulation in point of this advection dispersion study. These are the conclusions. The spring tide, tidal range, which is in our Indian coast, which is in the range of 1.12 to 1.2 meter, which is not that much high tidal range. Only in Kanyakumari we can observe the 5-meter range. This is the like maximum tidal range in our world itself is 6 meter, but in Kanyakumari we will observe 5 meter. And the neap tidal range is around 0.6 to 0.79 meter. And our Indian coast is a semi-diurnal and micro tidal region. If the tidal range is less than 2 meter, we will call as a micro tidal region. And current speed at the Ennore Creek. These are the like with it, we can see observe that the discharge of the river also plays an important role in the current speed of the Ennore Creek. First of all, with river discharge, it is 1.93 meter per second, and without river discharge, it is 1 meter per second. The variation in the current speed at the intake locations with wind, and we can observe that the wind also plays an important role in advection dispersion study, because from the wind, that U component and B component will be given as an input for the advection dispersion equation, which will affect the process of the dispersion. So without wind, only the tidal data is not sufficient to simulate the advection dispersion study, and no significant recirculation of hot water is observed, because the distance between the two outfall and intake location is sufficient enough so that the recirculation of hot water is not happen. That is a significant case that we have to taken care. Otherwise, that system of power plant will be damaged. And these are the critical cases. If you consider only tide, there is a more impact of advection. And in case 3, tide and river discharge is considered. It's also a more impact, but it's not an actual case. And these are the reference which I have gone through. If we want to simulate this type of simulations in as a part of a project work in BE final year, there is you can go through this Telemac 2D manual, and there are so many open source softwares are there. Only the thing is we are not aware of it. Otherwise, you can get a help from me, so that as a final year project you can do this type of simulations, and I can supply my material to you. Thank you. That's all.
Yes, Bathymetry.
Am I audible?
Yes.
Okay. Thank you, sir. It was a wonderful session. It was very informative as well. And if anybody has some questions, sir will answer them now.
You can even type it in the chat box. Okay. Ram, I have a question now. Yes. So I was working with Mike 21 modeling when I was doing my research. You must be knowing that. Now, what is the difference between this Mike 21 modeling and this Telemac?
Mike 21, I never used it, but usually it is used for the coastal line erosion, and that type of process will be used. But in this, all model uses the same shallow water equation. Only the difference is how that shallow water equation is processed, using what type of partial differential equation and what steps like. Okay, we can explain this. The method of processing will be different, and after the solving the shallow water equation, how that input is given. Like for sediment transport equation will be there. For that, this U and V component will be given as an input. For advection dispersion study, there is a different equation. Like various model will solve the various type of equation to simulate the process.
Okay, so you mean to say that the Saint Venant equation is the shallow water equation, correct? Yeah. Okay. Yeah, thank you. Thank you. Any other questions from the participants? Maybe it is very new and a new topic as such.
New topic and
I need to learn more. Let them work on it and then learn the open source. You have told no open source software is available, so let them work on it and then get back to us. We'll give them some time for learning process also. Yeah, fine. Any questions from Bathymetry?
Ma'am, I have a basic question, ma'am. What, Ram sir, what inspired you to go into ocean? Rather than just like mostly when people get into civil engineering, it will basically be because they watched a movie or something like that, like, but what specifically, like most of them, like when I got into civil engineering, I didn't know anything about it. I just thought, okay, fine, maybe someday I'm going to become a civil engineer and construct houses. But as I knew more about the field, I understand like civil engineering has like only 30 to 40% of construction, and it is a very vast field. So what made you specifically choose ocean technology?
Basically, I have chosen be civil engineering by seeing my grandfather. He is a civil engineer, and he is also an HOD in like retired HOD in Women's Polytechnic College. So I have seen him and got inspired and got into the BE civil engineering. And after getting into it, I came to know it's not like the previous. We won't get that many. Previously, it was like a less number of resource was there, and less people are going into that and getting that good job opportunity and everything. But now there is so many competition, and Bandra ma'am joined in my third year, I think so, third year or fourth year. So I chose as a guide, and through Bandra ma'am only I know there is a like a ocean engineering field is open for civil engineering persons to enter. Till that I don't know what is ocean engineering, because ma'am guide was Ramanamurthy sir from NCCR. She explained that these are the opportunities, openings are there. Just try. So I tried in NCCR, but I didn't get the job opportunity there. So I was frustrated, and again I talked with the ma'am, and she told from IET also there is also people are intaking the resource persons from civil engineering, so that you can try. So I tried and got the job opportunity. After joining, I came to that full field has been explored, and what are the opportunities, what are the easy way to get into it. Those things and all I explored and got into.
That is really impressive, sir. I'd like to go ahead with the vote of thanks if anybody doesn't have any questions anymore.
Yeah, before that, really, I really don't know what to say. Raam, what a transformation, Raam, when I saw you in 2018, 2017, I should say, during your project reviews, he will not speak a word, So like that he was, but he is always talented and he got a lot of stuff. He is really having a good potential. He was, I should say, as my UG student, but still he was not outspoken. Even now you can realize, but now what a transformation, the way you have prepared your slides, the way you have delivered talk. That too, he is giving this talk from Hyderabad. So you can make out the kind of, he is there right now. So that is why we have gone for online now. Else we would have invited sir to our campus now. So sir is so busy. That is why we chose Saturday, and it should be working day for all of us. So I'm really happy. I should say you made our day, and especially you made my day. I should say that. I'm really proud to have you as my student, and I'm always the well-wisher. So I wanted your juniors also to learn, and then I request you to support them. We will share your number, email ID with them, so that then and there you can teach them the software, how to use the open source. Even if open source is available, we are not even aware of this software. So that portion, again, I request you to help your juniors. And I wanted all the third year, final year, and even second year students are very, very good and studious enough. This girl, Bathymetry, she is a second year student. She is only hosting all the events in the department, I would say. So everybody is very interested to learn what's happening. for civil engineers? What are the opportunities? So we'll have a separate section for career opportunities for civil engineers in ocean domain, especially in government organizations. Okay, again, I request sir now itself to fix an appointment for us. Okay, sometime next month. Yeah.
Yes, ma'am. There are so many opportunities. Through you only, I came to know that there is an NIOT, NCCR, INCOIS, and
Yes.
remote sensing.
Remote sensing and GIS. I used to tell our boys, no. And this NIOT, we have signed an MOU with the National Institute of Ocean Technology and also with the National Center for Coastal Research. Dr. Ramanamurthy is our distinguished supervisor, professor for our department, and every 6 months he is delivering technical talk. So he is the director for that center, and he is able to reach our students. Even during pandemic, sir has given many webinars. So that is the pride of our department, I should say, and I am really so proud of you, Raam. Take care. Over to Bakrushi or over to the speaker. Yes.
Okay. I'd like, sir, please continue, please.
I want to tell some things related to this open source software. There are so many open source software, like from Delta RS University. Similar kind of hydrodynamic model is available, and this is Telemac, and there is an Delft dashboard. Ma'am, ask your students to check about the Delft dashboard. It is an GUI, just operating like application in our mobile network, like mobile. Like whatever the process which I have given, like mesh generation, that input boundary condition, it's all like a single click process. If you, there is a tutorial also, I can share the link of about that, so that they can easily try some tutorial cases, so that they can go for big, they can make it as a project for a BE final year, and supervisors from outside, like a final, they also will be surprised. This type of study we never seen.
Any external examiners. Correct. True. Always we do that. They all will be so impressed with our students' project work in their final year. This is a different domain, as you say. We will definitely incorporate all this. Yeah, good. And you can be our external supervisor also for helping our students with their project work in their third year as well as final year. Is it okay, Raam?
I will try my best.
Oh, sure. I know you will. Okay, fine. And please text all these links and tutorials, everything to me through WhatsApp, so that I can share it with my students also. Okay. Thank you so much, Raam. Thank you. Over to Bakrushi.
First of all, I'd like to thank Mr. Raam, sir. Sir, it is so nice of you to attend it from Hyderabad. I thought you were in Chennai, but you were like too busy to come here. But attending it from Hyderabad is like a really huge deal. And I really thank you for making this time for us. Also, thank you, ma'am. Like as sir said, you've been like a huge pillar of support to all our students. Like personally, anybody I know, they've been like supported some way or the other because of you. So thank you so much, ma'am. Thank you so much for this event. Thank you, sir, for attending this, making us all like know something that is a huge part of the field, but is going unnoticed every single day. So thank you so much, everybody, for also attending this event.
Thank you, Raam. Thank you, everyone.
One thing I have to share.
Yes.
Whatever I have shown, it's like so many images are there. Some students might not be understood, because I am also from that stage only. Because this thing have to be explored, and have to be as a part of a curriculum, make it to students to understand, and thank for this opportunity.
And Raam, we have become autonomous. So as you said, we will try to incorporate. Yes. So we'll try to incorporate these new and emerging latest techniques also in our curriculum. We'll try to do that.
Yes, like coastal engineering, make it as one course.
Definitely. Yeah. Why not? Not only in elective, why not as a core paper itself? Yeah, we'll do that. Yeah. Thank you so much. Thank you, Bakrushi. Thank you all. Thank you.
Thank you.